The Milky Way is a barred spiral galaxy that is approximately 13.6 billion years old and has long, splayed-out arms that can pivot. Los Cumbres Observatory estimates that the disk of our own galaxy is only 1,000 light-years thick and has a diameter of roughly 100,000 light-years. The solar system revolves around the Milky Way's nucleus, just as Earth revolves around the Sun. Our solar system rotates once every 250 million years despite traveling across space at a speed of about 515,000 miles per hour, 828,000 kilometers per hour, according to Interesting Engineering. When our planet was last in this situation, dinosaurs had just begun to appear, and mammals had not yet begun to emerge. We would be residing in a suburb of the Milky Way city, some 25,000 to 30,000 light-years away, if it were a real city. The quality of life in the periphery is good. We are located in the Orion Cygnus Arm, one of the smaller communities, situated between the bigger Perseus and Carina Sagittarius arms. The Scutum Centaurus and Norma arms can be found if we move inwards toward the city's core. We can see the dazzling lights of the galactic city blazing through the night sky on a clear night without any light pollution. Our galaxy, this milky white ring of stars, dust, and gas, is our window into the cosmos. Sagittarius A*, a supermassive black hole, is located at the center of the Milky Way. Its mass is around 4 million times that of the Sun, and it devours anything that gets too close. By eating on a plentiful supply of star debris, it can grow enormously large. In 2022, using a groundbreaking method that allowed us to see the black hole's shadow, we captured the first images of this gluttonous monster at the center of our galaxy. Our galaxy's home is known as the Milky Way, according to the American Museum of Natural History, AMNH, because of its apparent milky white look as it sweeps across the night sky. According to Greek mythology, the goddess Hera spilled milk across the sky, causing this milky band to form. The Milky Way is referred to by several names in different countries. For instance, it is referred to as Silver River in China and as the backbone of night in South Africa's Kalahari Desert. Although scientists believed that all the stars in the sky belonged to our galaxy until relatively recently, we are continually adding to our wealth of knowledge about the Milky Way. Astronomers Herbert Curtis and Harlow Shapley argued about the size of the universe and the possibility of island universes, galaxies, in the Great Debate in 1920, according to the National Academy of Sciences. Shapley was of the opinion that we were not in the center of the Milky Way and that it was far larger than previously thought. Additionally, he asserted that spiral nebulae like Andromeda are a component of the Milky Way. On the opposing side of the argument, Curtis did not contest Shapley's assertions that the Milky Way was much larger than previously thought, but he did assert that there were vast island universes, galaxies, outside the Milky Way's boundaries, including Andromeda. When Edwin Hubble's studies of Cepheid variable stars demonstrated that Andromeda was situated far outside the Milky Way, the argument was settled. The Andromeda Galaxy, which is our nearest galaxy neighbor, is thought to be 2.5 million light-years away. Astronomers have been attempting to determine what kind of galaxy the Milky Way is more lately. The best predictions we can make at this time indicate that it is a barred spiral, which means that the center is crossed by bars. By observing the Milky Way's population of stars and their spherical motions across the sky, astronomers can make an educated guess about the Milky Way's shape. We now understand that the Milky Way is one of over 30 galaxies that make up the local group, including Andromeda, Triangulum, and Leo I, to name a few. It turns out that knowing who your neighbors are is a good idea since they can be closer than you think. The Milky Way is now traveling at 400,000 kilometers per hour, 250,000 miles per hour. This cosmic crash won't occur for another 4 billion years, so there's no need to panic just yet. In order to understand what we might be up against when Andromeda and the Milky Way collide, NASA and other space organizations have been monitoring far-off galaxy mergers for decades. There is not much cause for concern, according to the short story, but the extended yarn about the process is intriguing because it describes how galaxies might develop. For instance, the renowned Hubble Space Telescope studies of a three-way galactic collision in 2022 revealed some fascinating details. The largest of the bunch snagged some material with its somewhat stronger gravity as it entered a close orbit with the other two. As a result, a fascinating streak of gas, dust, and other things pouring into the larger galaxy was generated. This streak was visible even from Earth. While this process will undoubtedly rip apart the Milky Way's arms, individual stars are comparatively safe because of the vast distances separating them. In other words, don't search for star collisions because there won't be any. The amount of gas being blasted into our galaxy will, however, cause starbirth to accelerate, brightening our galaxy and increasing its population over the ensuing millions of years after the collision. As a result of the minimal likelihood of star collision, our own solar system should be fairly safe. However, as the merger proceeds, we might find ourselves forced onto an entirely new route around the new galactic center. The constellations we can see from Earth may change as star orbits change or new stars are added to the mix. However, because the collision won't occur for millions of years, the constellations we can see now may change regardless due to natural star birth and star death that occurs independently of the collision. This time-lapse of the Milky Way demonstrates how the night sky will change over time. It used to be notoriously difficult to study the Milky Way. Astronomers have compared the endeavor to being lost in the middle of a forest while attempting to describe its size and structure. Simply said, we lack a broad perspective from our location on Earth. But two revolutionary satellite telescopes launched since the 1990s have contributed to the dawn of the Milky Way's scientific heyday. Significant progress has been made, particularly since the European Space Agency's ESA Gaia mission was launched in 2013. Before scientists knew they were gazing at galaxies, telescopes allowed astronomers to distinguish the fundamental form and structure of some of the nearest galaxies. But it took a long time and was laborious to recreate the form and architecture of our own galaxy. Building star catalogs, mapping out their positions in the sky, and calculating their distance from Earth were all steps in the process. The discovery that the Milky Way rotates was made by Dutch astronomer Jan Oort, who is frequently referred to as the master of the galactic system. Oort also computed the speeds at which stars at various distances orbit the galactic center. Oort was also responsible for determining where our sun is located inside the huge cosmos. After him, the Oort cloud, a collection of countless trillions of comets far from the sun, was called. The galactic disk extends past the bulge. The majority of the galaxy's stars, including our sun, reside in this feature, which is 100,000 light-years broad and 1,000 light-years thick. The disk stars are scattered throughout stellar dust and gas clouds. The edge-on image of this disk expanding toward the galactic center when we look up at the sky at night is what makes us gasp. The galactic bulge seems to be emitted like arms by swirling streams formed by stars in the galactic disk as they orbit the galaxy's center. Although investigations into the processes that give rise to spiral arms are still in their infancy, the most recent research indicates that, compared to the galaxy's 13 billion years of evolution, these arms form and disperse in comparatively brief intervals of up to 100 million years. Star formation is more intense inside those arms because stars, dust, and gas are more densely packed there than they are elsewhere in the galactic disk. Stars in the galactic disk therefore typically have a significantly younger age than stars in the bulge. Because the gas and stars congregate and move more slowly in spiral arms, they resemble traffic jams. Material is compressed as it travels through the tight spiral arms, which causes additional star formation in a statement, Denilson Camargo from Brazil's Federal University of Rio Grande do Sul said. That was for today. Thank you for staying with us. Don't forget to like our video and subscribe to our channel.